Is your favorite TV program often interrupted by advertising? CNBC presented statistics on the average number of programming minutes in a half-hour sitcom. The data below, in minutes, are representative of their findings. Assume the population is approximately normal. What is the population? Population would be all half-hour sitcoms. So we're studying half-hour sitcoms. What is the population parameter being studied? We are measuring the mean number of programming minutes. Provide a point estimate and a 95% confidence interval for the mean number of programming minutes during a half-hour television sitcom. So my sample mean would be the point estimate, and to get the sample mean I'm going to need to take the data in the table there and calculate the average on that data. And there are 20 values. So I'll basically add them all up and divide by the 20. Now this is a sample of half-hour sitcom shows. Not all of them, but just a sample. So my average taken from that sample is just going to be an estimate of the population average mu. I'll never know what mu is, but I can estimate it with the sample average. And calculating the average on that sample, my point estimate then for the mean number of programming minutes is 22 minutes. And I also, since the population standard deviation is not given, I'm going to have to estimate it with the sample standard deviation. So the standard deviation of those 20 data values in my sample turns out to be 1.119 minutes. Now, to get the 95% confidence interval, this is a confidence interval for the mean. So I'm going to have to now decide whether I'm going to use a standard normal distribution or whether it should be a t-distribution. And a couple things I notice here is that I'm working with the sample standard deviation, and my sample size is 20. That's a small sample. It's less than 30. So I need to be using a t-distribution. So my formula would be x bar plus or minus t alpha over 2 s over the square root of n. Now, for 95%, the t alpha over 2 would be t sub 0.05, that's alpha, divided by 2, or t sub 0.025. And the row that's located in is the degrees of freedom. And the degrees of freedom is the sample size subtract 1. So that'd be in row 19. And column would be the alpha over 2, which is 0.025. So I need to go to the t-distribution table to get that. So I want to go down to the degrees of freedom for the row, and then the alpha over 2, the upper end area would be 0.025, and I'm able to locate then the t value that I need. So 2.093, and then I can put all these into the confidence interval. So I would have 22 plus or minus 2.093 times 1.119 divided by the square root of 20. And that would be 22 plus or minus 0.5237. And 0.5237 then would be my margin of error. Now, since we're talking about time in minutes, 0.5237 minutes is approximately 31 seconds. In other words, about a half a minute. I got that by multiplying 0.5237 by 60. Now what the margin of error tells us is that I have an estimate. My 22 minutes is a point estimate of mu, but how close is that estimate? My average of 22 minutes is within 31 seconds of the real population mean mu. 95% confident of that. Now the confidence interval is that I would add and subtract 0.5237 to 22. So I would get, on the lower end, 22 subtract 0.5237, or 21.48. And then on the upper end, I would get 22.52. And this would be my confidence interval. And then to interpret that, or to explain what that tells me, I would say that we are 95% confident that the real population mean number of programming minutes is somewhere between 21.48 minutes and 22.52 minutes. So again, to summarize, I'm interested in the mean number of programming minutes of all half-hour sitcoms. What's the average number of programming minutes for all those sitcoms? Of course, I can't compile all that or get all that information, so I base it on a sample of 20. Hopefully this sample was randomly selected in a way that it's representative of the population. And I find that the average on the sample is 22 minutes. So that's going to be my estimate of mu. That's going to be my estimate of the population mean. Now the question would come in, how far off could I be there? Under 95% confidence or probability, I can say that that value is somewhere within 31 seconds of the real population mean mu, or somewhere between 21.48 minutes and 22.52 minutes.